Okay, so we're in our flip book again on triangle congruence proofs, and I am on problem 4, side angle side. You may need to pause until you find this proof. Okay, hopefully you have found the proof. On this one, we're going to use side angle side, so keep in mind you need two sides and an angle. So the given is that M is a midpoint of LP and NO. So we go ahead and write that in statement 1. M is the midpoint of LP and NO. They don't give me much room, and that's my given statement. Then the next thing you want to do is you want to go mark that on your figure. So we're going to look over here. It says M is the midpoint of L to P and N to O. So what that means is from L to M, that's going to be congruent from P to M. And then from N to M is going to be congruent from O to M because the midpoint splits both of those segments in half. So let's look what has happened. L to M and P to M being congruent is not listed under our statements. So we're going to go list that. So L to M congruent to P to M. And that is by definition. Look for your vocab word right here, definition of midpoint. Now we can say that for another one because we have N to M and O to M. N to M is congruent to O to M. That is also definition of midpoint. So you can sometimes use the same thing twice. Sometimes they'll write the two of these on the same line. So they'll just put a comma and put that one up there with it. And sometimes they'll write it on different lines. Okay, so what we have, if we're doing side angle side, is we have this two sides, but we do not have the angle. So first thing, always check, do you crisscross? Does LP and NO crisscross or intersect? And they do. That makes right here, these two pink marks, those two angles, are them vertical angles. Now remember, if I just said angle M, you wouldn't know what I was talking about. So I have to use 3 letters to name this angle. So I'm going to use L, M, N. So angle L, M, N is congruent. Now be careful. L is actually congruent to P. It's twisted, okay? So P to M to O. So angle P, M, O. And this is by definition of vertical angles. And we now have our angle. So you have side, angle, side. So you have proved the statement. So you're going to take your statement up here. You're going to write it just as it is. You're not going to change it. So triangle LMN is congruent to triangle PMO. And that is by side, angle, side congruence postulate. Okay, pause the video and write down all that you need to. All right, now we're looking at angle, side, angle. So think about this. You need two angles and a side. And they have some given information up here. And this is one of the parallel line ones that we haven't done. Notice there's no arrows on here yet to show us that the sides are parallel. But in our given statement over here, it says C is the midpoint of AD and AB is parallel. Remember the two little straight lines being parallel to CE, and BC is parallel to ED. So there's going to be some things that come out of that being parallel. So let's start with our first given statement. So C is the midpoint of AD. And this is a given. Now I'm going to do this a little different than stating all three givens back to back, because occasionally you see a proof like this, and I just want to give y'all an example. So they write C is the midpoint of AD, and since that's not like a congruence or anything, we actually go see what that means. So here's C, and it's the midpoint from A to D, which means it splits this in half. So from A to C, it's congruent to D to C. So congruent, congruent. We're going to go ahead and write that. So we're going to write AC is congruent to DC. And this is definition of midpoint. Now remember, the only reason I'm not writing the given statements is just show you another style of writing this. The next given is AB parallel to CE. And then this will be a given, so that you have givens strung out throughout your proof. So AB, you draw the arrow like this, and CE. When this happens, it looks like you kind of have two mountain tops here, or two ramps, however you want to look at it. You actually have parallel lines. And so this is your parallel line. This is your other parallel line. And then this blue line I'm drawing, this A, that is your transversal that cuts through here, which gives you these corresponding angles, one inside the two parallel lines and one outside of the parallel line. And corresponding angles are congruent. So I can actually say angle A is congruent. And then I run into a snafu if I wrote it like this. If I put angle C, because angle C could be multiple angles. So that's my clue to come back. And I got to use 3 letters, even though it doesn't matter for angle A. So angle BAC is congruent to angle ECD. And that is, by definition, of corresponding angles. All right, now we have one more given statement. We have BC parallel to ED. Here's your given. So sometimes you'll see them occasionally spaced out. Usually they put all the givens up front, but sometimes they space them out. So let me erase a little bit up here because we have a lot of stuff kind of drawn. And I'm going to go back and mark. So this was parallel to this, and this angle is congruent to this, and these are parallel lines. All right, now they're telling us BC is parallel to ED. So now your parallel lines are going this way. Same transversal because it's the line that cuts through both of those parallel lines, but your corresponding angles this time, one in between the two parallel lines, one outside. Okay, now we're going to run into the same thing where we need to use 3 letters. So we're going to do angle EDC is congruent to angle E. Hold on, I don't think that's an E. Let me back up, I got to erase. That's a B. Okay. To BCA. And this is, again, definition of corresponding angles. And my hint to you is that when you see this shape and they tell you any of these lines are parallel, you've got corresponding angles. All right, so we have actually proved angle, side, angle. So write your proof statement down here. And our reason for it is by angle, side, angle, congruency postulate. Okay, the rest of these proofs are for you to try. They will be due the Monday we get back from Thanksgiving break. Good luck.